Hello students, this video is for the quiz review from Unit 2, Lessons 1 through 3. Before I start with the quiz review questions, I want to go back to classwork 1 with you really quickly and explain a correction that I want you to make. Number 3 is one of the examples where when we found the inverse of this quadratic, we left this just a positive square root. And what we should have done is plus or minus, and I want to show you why. When I go and graph this quadratic on Desmos, and then I graph its inverse, you see I have the red is the original and the blue is the inverse. And as you can see, it's a parabola, and then it's not really it's not a function, but it's still this parabola that is the inverse, and they do reflect over the y equals x function. If I were to just put in, or if I were to just graph the positive version, the positive of this square root function here, what I would get, I did that on another Desmos page, what I would get would be just this, because this is a square root function. This is what a square root function looks like. This is not what a parabola looks like, so it's not like an x squared function. It's not what it looks like. So we have to also include the negative piece of that to make it to where it's actually the inverse. And remember on that classwork we said no, that the inverse is not a function, and this, just the positive part of it, would be a function. So with just the positive piece, it's not really the inverse of this. It's basically half of the inverse of this because there's a domain restriction. So go back on number 3 when you get that back and enter positive or negative. Or just remember, when you have one like this, when you have to square root both sides, you need to make sure that you put the positive or the negative on there. So another example of this would be number 15 on the classwork 1. And that was a log function, and it had an x squared in it. And at the end, when we got the inverse, it ended up being a square root function again. And so we need to also put the plus or minus here. I'm just going to show you what those look like. So the log function looks like this. And the just the positive inverse looks like this, and so that's only half of the inverse, and so we would have to include the negative piece of that for it to actually be the true inverse of this purple function. And the last one on classwork 1 is I think it's number 16. I don't have that one up here, but that one was also ended up being a square root. So I want you to make sure that you correct that one and put a plus or minus. So anytime you have square root both sides, go ahead and do the plus or minus. It works in equations, and it also works with these functions. All right, let's get started with the quiz review. This quiz is going to be on lessons 1 through 3. So you will have some solving equations, solving exponential and log equations. You will also have inverse, finding the inverse, domain, and range. When you solve log equations, you're going to want to check your solutions because some of them will work and some of them will not work. All right, number 1, we have two bases that are the same. Both of the 8s are the same, and we don't have more than one 8 on this side. If you have more than one base on the left side or the right side of the equals, you need to combine those first before you mark out the bases. So let's mark out the 8s, and we'll set this up with the exponents equal to each other and solve for x. All right, number 3. So on this one, we have two 4s on the left side. So we need to combine these two. And if you remember your exponent rules, let's say you have n to the 6th times n to the 2nd. You combine the n's, and what you do is you add the exponents when they're multiplied times each other. So we're going to do the same thing here. We're going to combine those 4s, and then we're going to add the exponents. So we have x plus 1 and 2x minus 6, and when we combine those, that's 3x minus 5. So this is 4 to the 3x minus 5 equals 4 to the negative x plus 2. So now we can mark out the 4s and set these up equal to each other. And then we'll solve for x. So I'm going to add x over here and add 5 here. Then divide by 4. You can leave it 7/4, or you could do a decimal, but this is fine. Okay, so the next section is still solving the equation using like bases, but these don't start out with the same bases. So we have to figure out how to change these bases. So let's look at this one. We have a base of 5 and we have a base of 1. Anytime I have a 1 here, I can change that to anything to the 0 power. So I can change this side to 5 to the 0 power, mark out the 5s, and then set up the exponents equal, solve for x. You can leave this 5/2, or you can divide that and use your decimals. So either way is fine. Okay, so here we have 3 different bases. We have a 3, a 9, and an 81. And I know that all of these can be written with base 3. So let's do that first. Remember that if you rewrite something with a different base, you need to keep that exponent up here and then multiply it. So this is going to be 3 squared. So that squared goes up there and it gets multiplied times that original exponent. And then 81 is 3 to the 4th power. So I still can't drop these 3's yet. I need to combine these two first. So let's combine the 3's, and this is going to be, let's see, we'll do this over here. This is p minus 3, and this is negative 4p plus 14. So when I combine those, that's 11. This is where we can mark out the 3's. So my personal preference is to leave these in fractions. It's more accurate than using a repeating decimal. Number 9. This section says solve each logarithmic equation using like bases. And I'm just going to tell you, number 8, when you do your check step, you will find out that it does not work, because when you do the check step, it ends up giving you this. And even though that looks like it checks out, you cannot have a negative number in here. So your answer for number 8 is no solution. All right. Number 9. So these are both log base 10, so we can cross out the log, set these up equal to each other. Okay, so I need to check this. So that checks out. Number 11, both of these are natural logs, which is log base e, of course. So cross that out. So at first when you see this n squared, you think, oh, I'm going to have a trinomial, but there's no n term. So we just need to add 16. And we get n squared equals 36, which means n equals plus or minus 6. I'm just going to separate that. And you need to check each one. And of course, I know that if I put -6 in there, that's going to be 36, and 36 minus 16 is going to give me 20, so actually they both would check out, so they're both solutions. I was originally only going to work the odds, but this one is an exponential, and I want to make sure I do one exponential and one log function. For some reason this is not giving me a pen. It's still on eraser. There we go. Okay, so number 12 is an exponential function. You can go over to Desmos and you can graph this and see that the domain is -infinity to +infinity. And then when we get the inverse, we'll look at that as well. So we need to isolate this part right here. The base and the exponent need to be isolated. So I'm going to divide both sides by 3. Let's rewrite this first. Sorry. 17. I want to make sure. Yeah, 17. Okay, so now let's divide by 3. So this is the point where we put it in log form. So I know that I've got log base 6. If you remember that the exponent is always what goes over here after the equals, then you'll know that the x over 3 is what goes in the parentheses. Okay, so that's how that's set up. And now what we can do is subtract 17, because we're still trying to solve for y, so we need to subtract 17 on both sides. And then we're just going to rewrite it. Let's see, this was f of x. And if you go graph this on Desmos, you'd see it, but you can also just switch the domain and range from the inverse of this or from the original. Number 13's back here. Okay, number 13. This one starts out as a log function, and it's going to switch to an inverse function. If you're kind of catching on to the pattern here, you know that this part right here, if you set this up equal to 0, that's going to give you the asymptote for this log function. And so that makes the domain +6, +infinity. And the range, of course, is always the same. Okay, so we have, let's rewrite this. We need to isolate this part right here, so we need to just subtract 2. And then we're going to write it in exponential form. 5 is the base. Remember, this part right here is the exponent. If it helps you to rewrite it the other way, then do that. Okay, so now we need to just add 6, and I'm just going to go ahead and rewrite this in inverse. Remember, we're going to add 6 to this. Okay, well, you don't need to do that part down there since I already did that. And then switch the domain and range. Remember, in the range, or actually don't remember, we haven't talked about this, but if you're catching on any of these patterns, in an exponential function, the range, this is the horizontal asymptote, and this is a positive number, so that means that it is above the asymptote. So your range is going to be 6, +infinity. Okay, just get used to the fact that anytime you see an E, especially if it's this little italic E, little cursive looking E, that is natural log. So it is log base E, and I kind of like to think of it that way as I'm working with it, but we end up having to use the LN. So we want to isolate this right here. We're gonna, when we rewrite it, Okay, and then we're going to add 4. So instead of writing log base e, we're going to use ln. That means log base e. And then in parentheses, your x plus 4. And then, of course, your exponent is always over here. Now, we can just think about these 2 steps at one time. We're going to subtract 1, and then we're going to divide by 2. So then we just need to rewrite it. I don't think I can fit it in there. Okay, so let's look at domain and range. Okay, so your exponential function, of course, domain is what it always is. Range. So this -4 right here tells me that the range, the horizontal asymptote is at -4. And it also goes to positive infinity. It's above the asymptote. Sometimes it'll be below the asymptote, but this one is above because this is a positive number. Okay, and then switch that. Set this up equal to 0. That gives you that vertical asymptote. And the range. So number 17 is asking you to rewrite this using change of base formula. So we're going to write log 7.59375 divided by, make sure when you put that in your calculator you put those parentheses around it, log 1.5. So it's asking us to rewrite it and then evaluate it. Evaluate means find the answer. So when you put this in your calculator, you get 5. Number 18 has 10 problems that go in it, and you've been asked to solve each equation, show the steps for credit, and round to 3 decimal places. These are all equations, so we're going to actually get an answer, and they give you the answer. So you should get this when you're finished. This is a natural log problem, so it's base E. What I need to do is isolate this part right here. So I need to, y'all be sure you understand, you need to multiply times 4. You're not multiplying times 1/4 or dividing by 4. That doesn't do anything. To get rid of the 1/4, you have to divide by 1/4. Well, divide by 1/4 equals times 4. So we're going to multiply them. Okay, so that's after I multiplied times 4. Now, I'm going to rewrite this in exponent form. Now, this is log base E, of course. So that means E to the 12th power equals this. So let's rewrite it that way. Let me see if I wrote, oh yeah, I did. Okay, so log E to the 12th power, I'm going to round this. I got 162,754.7914. I'm pretty sure I left this in my calculator, and then I subtracted 191, and then I hit enter, and then I divided by 5. And so what I got was, and we use these little squiggly lines because it means this is an approximation because I had to round. I got 32,550.958, and I think that was the answer you were given. Okay, so when I look back, I see that they have a 7 here, but this is what I got. Check and see if you get the same thing that I got. And I don't remember when I worked this if I used this specific number or if I left my answer in the calculator and then subtracted and divided. So see what you get and tell me if you got something different. Okay, so this is the third problem down. Yeah, this is what I called C. All right, this is a log function or a log equation, and we need to isolate this part and then rewrite in exponential form. So we're going to subtract 9, and I'm just going to do this. It's going to make that a 4. Okay, so now I can write it. This is log base 10, remember that. So 10 to the 4th power equals this. Well, I need to write 10 to the 4th power. That's 10,000. And then when I multiply that times 3, that's 30,000. And then I'm just solving for x. Because I like for my variable to be over there on the left, I'm going to switch this around. Divide by 151. Okay, so that time I did get the same thing that they had, the same answer that we were given. Okay, so this one is what I'm calling 18E. I put letters on these. So this one is the next one I'm going to work. And this is a log equation. So let's see, we need to isolate this part right here. So I'm going to multiply times 2.3. And when I do that, I'm just going to mark this out. I'm not going to write so much. When I do that, I get 25.3. And then I need to subtract 21.4. And when I do that, this is isolated, and that's going to be 3.9. So 8 to the 3.9 power equals x. So when you raise 8 to the 3.9 power, and my answers match. Okay, this is 8G, and we should get x equals 40, not just an estimation on this one, so we won't have to round anything on this one. I need to isolate this part right here. So I'm going to subtract, add 7 first. So then I need to divide by 2. And we can just leave this 7/2. So then I can write this in exponential form. 4 to the 7/2 equals x plus 88. So 4 to the 7/2 power is 128. You could also put 3.5 there if you wanted to. X equals 40. Okay, so this is the last one I'm going to work. This is a good one because we do end up having to actually use the E key on this one. So let's isolate this part right here by dividing by 8. And then we are going to write this, if we think of this as log base E, then we can kind of figure out where everything goes. E to the negative 3 power equals this right here. All right, let's go over to our calculator. Okay, so I can do this on my iPhone pretty easily. I tried the E to the X button, but that got me an error. And then I tried to do E to the negative 3rd power, and that also got an error. So here's what I had to do. because let me go back over here. Because e to the negative 3 is the same as 1 over e to the third power, I just changed it to that in the calculator. So I did 1 divided by second, here's the e, and then the caret key to the third power, and that gave me this. Okay, and then the rest of this was, let's see, let me make sure I got the right one. We need to add 5, and then we need to divide by 2. So I'm going to do that. Plus 5 equals, and then divide by 2, and that's 2.525. Yep. All right, so that worked, and that's what the answer was there. All right, I think that was the last one I'm going to do. So if we have school, I'm doing this on Thursday afternoon. If we have school Friday, then we'll be going through these in class. You'll be working on these during class. If not, then hopefully this video helped over the weekend while you were working on the quiz review, and I'll see you Monday.